Hello everyone! In this video we're going to go over the KutaSoftware Infinite Algebra 2 free worksheet Permutations. I'll leave a link in the description below so you know how to access this free worksheet. Now, for numbers 1 through 4, it says to list all possible permutations. And what exactly is a permutation? Well, a permutation is a way of ordering items where that order matters. So if we were to list all the permutations for number 1, well, the first one, we can have 1, 2, and 3. But we could also switch up position 2 and 3 and have 1, 3, and 2. There's no other way to order it with 1 starting, so now let's start with 2. Well, we can have 2, 1, 3, and then we can have 2, 3, and 1. And then lastly, if we start with 3, we can have 3, 1, 2, or 3, 2, 1. So let's move on now to number 2. In number 2, again, we're listing the different permutations. But this time we're only taking 2 as opposed to taking all 3. So let's go ahead and write our first permutation starting with t. Well, we can have t and then v. Well, starting with t again, we can have t and w. There's no other way to order that, so let's move on to our next letter. We can start with v and then take t, or we can do v and w. No other ordering to that, so now let's move on to w. We can start with w and then t, or w and v. And again, for a permutation, the order matters. Look, even though I have the same exact letters, v and w, vw is not the same thing as wv. They are two completely different permutations because the ordering does indeed matter. Let's move on to number 3. In number 3, again, we're taking these items 2 at a time. It's a smile, sun, heart, and triangle. This time, however, there's 4 as opposed to previously there was 3. When there was 3, we got 6 different combinations. Let's see how many we get when we have 4. Well, we can start with a smile and then do a sun. We could have a smile with a heart, or we could have a smile with a triangle. Now, if we were to start with the sun first, we can have a sun with a smile. We could have a sun with the heart. We could have a sun with a triangle, and that's about it for that. Let's move on again. Well, we've already started with smile and sun, so now let's start with heart. We can have heart with smile. We can have heart followed by sun. And remember, again, heart followed by sun is completely different than sun followed by heart because this is a permutation. And lastly, we can have heart with triangle. One more symbol we haven't started with was the triangle. So we could do triangle, smile, triangle, sun, and then triangle, heart. So how many different permutations do we have? We've listed them, but how many are there? 3, 6, 9, 12 different permutations. And I could have figured out how many we would have without even listing them out. And let me show you something real quick. Let's go back to number 2, because I think this will be helpful for later in our worksheet. If we go back up to number 2, we were taking 2 at a time. So out of those 3, taking 2 at a time, here's 2 different slots. How many different letters can fill the first slot? 3. How many different letters can fill that second slot? Well, if I've already used up 1 letter at that first slot, only 2 can. 3 times 2 equals 6. That's my 6 different permutations. Now moving back to 3, think about it. Taking 2 out of the time, 2 slots. How many symbols can fill that first spot? Well, there's 4 different symbols, and then once we choose 1 for this first slot, how many symbols are left? That's 3. 4 times 3 equals 12. And indeed, there were 12 unique permutations. But this asked us to list them out, so we did. Let's move on to number 4. In number 4, we have A, B, C, and D, and we're doing the permutations for this. And it doesn't say how many we're taking at a time, so we know we're going to utilize all 4. So let's make 4 slots, 1, 2, 3, 4, and figure out how many permutations we're going to list before we do all that work. Well, The first slot, there's 4 different letters to choose from, and then there's 3, and then once we use those 2 letters, there's only 2 left, and then for our last slot, after we use 3 letters, there's only 1 potential letter we can use. This 4 times 3 times 2 times 1, counting down like this and multiplying each of them, that's known as a factorial. So this is equal to 4 factorial, and we can solve this. 4 times 3 is 12, times 2 is 24. So I hate to break it to you, but we're going to have to list 24 unique permutations of these letters A, B, C, and D. So let's get started, and I'll try to make this as easy as possible. We're going to start with the letter A. Starting with the letter A, we can have A, B, C, D. We can have A, B, and then switch the last 2, D and C. We could have A, C, B, and D. A, C, D, and B. And then A, D, B, C, or A, D, C, B. Notice how I did this? I just whittled down starting with A first and listed all those different possibilities. Starting with A, then I went through having B as the second letter. And then once I filled that out, then I went through having C as the second letter. And then finally, I went through having D as the second letter, just to help me stay organized. So let's do this now using B as the first letter. Well, with B as the first letter, I can have A as the second letter with a C followed by a D. Starting with B and still using A as the second letter, I can have D and C. Notice there's no other way I can use A as the second letter and get a new unique permutation. So I'm going to move on to a new letter that starts second. So still continuing B, I'm going to now have C come next. So that means I can do an A and a D, or I can do a D and an A. Still starting with B, my final letter that I can choose from for the second letter is going to be D. So I can get B, D, A, C, or B, D, C, A. Notice this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're already halfway there. So now we're going to start with C. So we can have C, A, B, D, C, A, D, and B. Then C, B, A, D, followed by C, B, D, A. C, D, A, B, and then C, D, B, A. Notice I'm still using that same pattern, switching up my letters as I go. And lastly, now that we're at 6, 12, 18, there's 6 more unique permutations, and that's starting with D. So we can have D, A, B, C, or D, A, C, B. We can have D, B, A, C, or D, B, C, A. We can have D, C, A, B, and then finally D, C, B, A. 24 unique permutations. Let's move on to our next set of directions, now that we've listed all those permutations. Our next set of directions state to evaluate each expression. Now this may be new, but this P stands for permutation. But what's different than what we did up above, we're just calculating how many permutations there are. This number in front, 4, in the formula that will be in, and the second number following the P is our R. So this is how many ways or how many unique permutations there are if we have in objects, but we're only choosing R of them. So let me write down the formula and then we'll go over number 5. So the formula for in P R, that's in factorial over in minus R factorial. Note these parentheses, we have to do the subtraction before we do the factorial. And remember, for example, if we were doing 5 factorial, it'd be 5 times 4 times 3 times 2 times 1, and so on. So what I recommend whenever doing these formulas by hand is to simplify as much as possible. So if we were to fill this in, we would get 4 factorial over 4 minus 2 factorial. So that's going to be 4 factorial all over 4 minus 2 factorial is 2 factorial. 4 factorial, remember, is 4 times 3 times 2 times 1. And 2 factorial is just going to be 2 times 1. Notice when simplifying, 2 times 1 cancels out with 2 times 1. This is going to leave me with 4 times 3, which is 12. And this number should be familiar, right? Let's scroll right up to number 3. In number 3, we had 4 different objects to choose from, and we were taking 2 at a time. 4 different objects to choose from when we're taking 2. 4 choose 2. 4 times 3 was 12. That's exactly what we got down below. 4 objects taken 2 at a time. And remember, the order for this matters. Let's move on to number 6. In number 6, we have 5p1. Remember our formula. NPR is equal to n factorial over n minus r, that quantity, factorial. So working this out, this is going to be 5 factorial over 5 minus 1 factorial. That is 5 factorial over 4 factorial. And let's think about this. 5 factorial is 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. Look at all that's going to cancel out. All of this. So we're left with just 5. So 5 is our solution for number 6. But before continuing on much further, I just want to show you, we could have wrote this in an even easier way. We know we have 4 factorial in the bottom, and that 4 factorial is less than 5 factorial. So we could write 5 times, what was 4 times 3 times 2 times 1? This in itself is 4 factorial. So I'm just going to write 5 times 4 factorial all over that 4 factorial. So without writing all those extra numbers, we know our solution's 5. So keep that in mind when you're dealing with larger numbers. Let's move on to number 7. For number 7, we have 6 for n and 2 for r. So that's going to be 6 factorial over 6 minus 2 factorial. 6 factorial over 6 minus 2 is 4, so that's 4 factorial. That's equal to 6 times 5 times 4, and we can write the rest, but notice 4 factorial is in our denominator, so as opposed to also doing times 3 times 2 times 1, let's just put that factorial on the end of 4. Now we can cancel those out. 6 times 5 is 30. So 30 is our solution for number 7. But remember, feel free to write out 4 times 3 times 2 times 1 if you still need to see how these cancel out. That's completely okay. Let's move on to number 8. For number 8, we have 6 and 6. 6p6. So that's going to be 6 factorial all over 6 minus 6 factorial. That's going to be 6 factorial over 6 minus 6 is 0. So that's a 0 factorial. Now, you can't divide by 0. We know that that's not possible for a fraction. But 0 factorial is equal to 1. One way I like to think about this is, how many different ways are there to arrange 0 objects? Well, if you have no objects, there's one way to arrange all of those objects. It's by not arranging them at all. So 0 factorial would just be 1. So if we have 6 factorial over 1, that's just 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Let's do this out. 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. Multiplying that by 2, that's going to give us 720. So 720 is our solution for number 8. For number 9, it's the same deal as before, except now we're just going to be adding a negative 4. So this is going to be negative 4 plus, what's 7p4? Well, use our formula. That's 7 factorial over 7 minus 4 factorial. So this is going to be equal to negative 4 plus 7 factorial over 7 minus 4 factorial, is 3 factorial. Let's keep simplifying it down. This is going to be equal to negative 4 plus 7 factorial, but we can count this down until we hit 3 and then write it as factorial. So 7 times 6 times 5 times 4 times 3 factorial, because that 3 factorial is in the denominator, so I can just stop there because it will cancel out. So rewriting this, I have negative 4 plus 7 times 6 times 5 times 4, which, multiplication first, doing the order operations, 7 times 6 is 42, and then we have 5 times 4, which is 20. So continuing this in our heads, 42 times 20, well, 42 times 2 is 84, so 42 times 20 would be 840. So we'll have negative 4 plus 840. So subtracting 4 from 840 leaves us with 836. So 836, our solution in number 9. Now moving on to number 10, we have 5 times 6p5. So that's going to be 5 times 6 factorial all over 6 minus 5 factorial. That's going to be 5 times 6 factorial over 1 factorial. 1 factorial is just 1, so this is going to be 5 times 6 factorial. So we'll have 5 times 6 times 5 times 4 times 3 times 2 times 1. And here we go, just simple multiplication. 5 times 6 is 30, 5 times 4 is 20, 20 times 30 is 600. We're multiplying that by 3, which will give us 1,800, and then multiplying that by 2, which will give us 3,600. Finally, multiplying it by 1 is just 3,600. So 3,600 is our solution in number 10. For our next set of directions, it says find the number of unique permutations of the letter in each word. So looking at number 11, there's 1, 2, 3, 4, 5, 6 different letters, and each letter is different. Arranging them, that's going to be 6 factorial. 6 factorial, we know, is 6 times 5 times 4 times 3 times 2 times 1, which is 30 times 4, 120, times 3, 360, times 2, that's 720. Moving on to number 12. There's 4 unique letters, and we're trying to find how many permutations we have. That's going to be 4 factorial, which is 4 times 3 times 2 times 1, which is 12 times 2, or 24. Moving on to number 13. 13 is a little bit different because we have 1, 2, 3, 4, 5, 6, but those letters aren't unique. E is 3 different times. So because E occurs 3 different times, even if we switch these E's, it wouldn't really matter because E is the same exact letter. So how exactly do we do this? Well, we know we have 6 different slots. So that's going to be 6 letters in the first slot, and then we have 5, and then 4, and then 3 left to choose from, and then 2, and then 1 left to choose from if we started left to right. So that's going to be 6 factorial. However, because 3 of those letters, E, E, and E, are the same, how many different ways could we arrange E? So we're going to have to divide by those permutations that we would have counted. So we're going to have to divide by arranging those E's where order did matter, which it does for a permutation, but because they're the same letter as described before, switching those doesn't make a difference. So we're going to divide by 3 factorial. Because think about it, if these had subscripts, 1, 2, and 3, E1, E2, and E3, how many different ways could we arrange those? 3 times 2 times 1. Or 3 factorial. But they don't have those subscripts, so E is that same letter. So we got to divide by those permutations we made when doing the factorial in the numerator. So dividing that out, that's going to be 6 times 5 times 4 times, go ahead and stop at 3 factorial because that's getting crossed out. 6 times 5 is 30, times 4 is 120. So 120 is our solution in number 13. So let's remember that as we move forward. In number 14, how many letters total? 1, 2, 3, 4, 5, 6. There's 7 letters total, but look, R and R are not unique. Everything else is, but there's 2 of the same letter. So if I was to switch the ordering at any point in time as I write this out, that doesn't matter. So although there's 7 factorial permutations of these letters, because switching the placements of the R's in any of those permutations doesn't matter, I need to divide by that 2 factorial. So that's going to be 7 times 6 times 5 times 4 times 3 times 2 factorial all over 2 factorial. Doing this math out, 7 times 6 is 42, 5 times 4 is 20. So multiplying 42 by 20 is going to give me 840 because 42 times 2 is 84. So 42 times 20 is 840. Multiplying that then by 3, quickly on the side here, because that one's a little bit trickier to do in my head. 840 times 3, 4 times 3 is 12, carry the 1, 8 times 3 is 24, plus 1 is 25. So 2,520 unique permutations. Let's move on to number 15. In number 15, our word is ballistics. How many letters are there total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 factorial different permutations. However, there's quite a few letters that are repeated. Let's take a look. L occurs twice, so we're going to have to divide by 2 factorial, but I also occurs twice, so that's dividing by another 2 factorial, and then so does S. S occurs twice as well, so that's dividing by another 2 factorial. So we're going to have 10 factorial over 2 factorial times 2 factorial times 2 factorial. This one might just be easier to write out. So we have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's all over 2 factorial, which is 2 times 1, times 2 factorial, which is 2 times 1, times 2 factorial, which is 2 times 1. And yeah, I don't really need to write the ones, but I just want to show you that it is indeed that factorial. But multiplying by anything by 1 is just itself. So simplifying, 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8. So this denominator is actually 8. And where is there an 8 up above? Right there. So now I just do out my math, 10 times 9 times 7 times 6, and so on. And this one might be a little bit hard to do in our heads, but let's try it out. 2 times 3 is 6, 5 times 4 is 20, so 6 times 20 is 120. So this all multiplied together is 120. 7 times 6 is 42, and 10 times 9 is 90. So I know that 12 times 9 is 108, so 20 times 90 would not be 108, but 10,800, and I still have to multiply that by 42. So writing this out the long way, just so I can do my multiplication, 10,800 times 42, that's going to be 0 times 2, 0, 0 times 2 is 0, 8 times 2 is 16, carry the 1, 0 times 2 is 0, plus 1 is 1, 1 times 2 is 2. Now, putting my placeholder 0, since I'm done using that 2, 0 times 4 is 0, 0 times 4 is 0, 8 times 4 is 32, 2, carry the 3 now, 0 times 4 is 0, plus 3 is 3, and then 1 times 4 is 4. Adding that all together, and sorry it's a little hard to see over these words, but that's 0 in the ones, 0 in the tens, 6 in the hundreds, 3 in the thousands, 5 in the 10,000s, and 4 in the 100,000s. So 453,600 different ways to write the letters in ballistics. Let's move on to number 16. In number 16, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So that's going to be 11 factorial for the different permutations. But wait, Some of those letters are repeated, so we're going to have to divide. So let's go down the list. B only occurs once. I occurs 1, 2, 3 times. So that's going to be 3 factorial we're dividing by. L occurs twice, so that's 2 factorial. We already looked at I. O occurs once, N occurs once, A occurs once. We already looked at I, R, and E. So we're dividing 11 factorial by 3 factorial times 2 factorial. So that's 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's 11 factorial all over 3 factorial, which is 3 times 2 times 1, times 2 factorial, which is 2 times 1. 3 times 2 is 6. 6 times 2 is 12. I don't have a 12 to cancel out, but if 3 times 2 is 6, I can cancel out the 6, and 2 times 1 is 2, I can cancel out the 2. So I'm really working with 11 times 10 times 9 times 8 times 7 times 5 times 4 times 3 times 1. But I won't bother writing that 1. So let's go ahead and multiply this out. And just for the sake of time, let's use our calculators. Typing this in, we're going to get 3,326,400 ways to arrange the letters in billionaire. So think about that if they asked you to list all those different combinations like we had to do in numbers 1 through 4. That would take a very long time. But with that being said, let's just finish out with this worksheet, moving on to our critical thinking questions. And if you haven't already and you found this video helpful, don't forget to click that thumbs up button. Or if you were confused at any point during this worksheet, please let me know in the comments below, and I or one of your peers will get back to you as soon as we can. So for number 17, it says to write a word for which there are 30 unique permutations of the letter. So think about it. We need 30 unique permutations. So one easy way to think about this is, do we have all unique letters? If we scroll back up to number 12, 12 was the word math, and we used 4 factorial, which was 24. Writing that out, it isn't quite 30, so we know we need at least 5 letters. But what is 5 factorial? Well, that's going to be 24 times 5, because it's 5 times 4 factorial, which is 120. So we're going to have some repeated letters in there. So if we know that 5 factorial can be in our numerator, what do we have to divide by to get to 30? Because 30 goes into 120 evenly, it goes in 4 times. So we know that 30 equals 5 factorial over 4. But remember up above when we were working with the letters, when we found letters that were repeated, we divided by the factorial of how many repeated letters there were. This 4 isn't a factorial, but can we turn it into one? Totally. We can do 5 factorial over 2 factorial times 2 factorial. Because remember, 2 times 1 times 2 times 1 gives us that 4. So our word has to be 5 letters long where 2 letters are repeated. So one case of this is level. L-E-V-E-L. We have 5 letters with L occurring 2 times and E occurring 2 times. And this was the word that they put on the solutions. Can you think of another word? So one that I can think of off the top of my head would be something like seeps. S-E-E-P-S. S occurs twice and E occurs twice. And there's 5 letters total. So if something seeps through the cracks, or for a silly one, how about poops? P occurs twice, and so does O. Try to come up with a word all on your own. Moving on to number 18, it says to simplify x, p, x minus 2. Remember, our formula is n factorial over n minus r factorial. We're just working with variables now. So we're going to have x factorial, because that's our n, all over n, which is x, minus our r, x minus 2, factorial. Again, n is x, and x minus 2 is that r. So let's simplify this down. We'll have x factorial all over x minus 2. Well, distributing this negative through, x minus x is going to be 0, minus a negative 2 is going to be 2 left within these parentheses. So that's x factorial all over 2 factorial, which 2 factorial, 2 times 1 is just 2. And with that, we wrap up this worksheet. If you have any questions, please leave them in the comments below. And again, I'll have a link to this free worksheet in the description box below as well. And as always, don't forget to like, subscribe, and share.